In the Bekaa Valley of eastern Lebanon, beneath the ruins of a Roman temple complex, lies a quarry that has never stopped asking questions of the people who study it. The site is known as Baalbek. Long before Rome claimed it, this ground was sacred to older gods, a place of worship stretching back, by some estimates, over 9,000 years. But it is not the temples above ground that draw engineers and historians into quiet disbelief. It is what sits half buried in the quarry, roughly 800 meters from the main platform. 3 stones, cut, shaped, and abandoned. The largest of the 3, known today as the Stone of the Pregnant Woman, weighs an estimated 1,000 tons. A second stone nearby weighs close to 1,242 tons. In 2014, archaeologists uncovered a third block beneath it, still partially embedded in the bedrock, estimated at 1,650 tons. To put that in perspective, a fully loaded Boeing 747 weighs roughly 400 tons. This single block of limestone outweighs 4 of them combined. And yet these 3 giants are not even the largest stones at Baalbek. That distinction belongs to 3 blocks already in place within the temple platform itself, the trilithon. Each stone measures nearly 19 meters long, over 4 meters high, and 3.6 meters thick. Each weighs an estimated 800 tons. They sit in a wall roughly 7 meters above ground level, fitted so precisely against their neighbors that a knife blade cannot slide into the seams. No crane in the ancient world is documented as capable of lifting such weight. No wheel, no sledge, no known combination of ropes and timber rollers has been definitively proven to move a single piece stone of this mass across even level ground, let alone raise it 7 meters into the air. Modern engineers have proposed answers. Some suggest massive teams of laborers, thousands at a time, using wooden rollers and lubricated tracks, a method with precedent in Egyptian stone hauling reliefs. Others propose an elaborate system of earthen ramps, gradually built up and removed as the stone was walked into position using levers and counterweights. A more recent theory suggests the builders used a walking technique, rocking the stone side to side on a curved wooden cradle, essentially inching it forward one controlled tip at a time. Each theory has been tested. Each has partially worked on smaller stones, under controlled conditions, with modern safety equipment standing by. None has been demonstrated at Baalbek's actual scale, using only materials and methods confirmed to exist at the time of construction. The identity of the builders responsible for the platform's foundation remains disputed as well. Roman engineers undoubtedly built the temple complex above it in the 1st century BC. But growing evidence suggests the massive foundation stones predate Roman occupation by a significant margin, that the Romans built on top of something already ancient when they arrived, choosing not to move stones they likely could not have moved themselves. If that theory holds, then whoever quarried, carved, and positioned those original blocks left behind no written account of how it was done. They left only the platform, the abandoned quarry stones, and the unmistakable evidence that they intended to move an even larger stone before. For reasons unknown, they simply stopped. Why abandon a nearly finished 1,650-ton block, mere meters from where it was cut? Did the technique fail? Did the stone crack in a way not visible today? Or did something else entirely intervene? The quarry has kept its silence for thousands of years. It shows no sign of changing that now. High on the Bolivian Altiplano, at an elevation of nearly 3,850 meters, sits a ruin so precisely cut that early 20th century archaeologists initially assumed it must be a hoax, or at the very least, a much later construction mistakenly attributed to an ancient culture. Puma Punku is part of the larger Tiwanaku complex, believed to have been constructed sometime between 500 and 600 CE, though some estimates push the origins significantly earlier. What remains today is fragmentary, a scattered field of massive stone blocks, many broken, some seemingly untouched by 1,500 years of Andean weather. The material itself presents the first mystery. Much of Puma Punku was built using red sandstone, quarried roughly 10 kilometers away and transported without the benefit of wheels or draft animals suited to the terrain. Llamas can carry perhaps 45 kilograms, nowhere near sufficient for blocks weighing up to 130 tons. But the more perplexing material is andesite, a volcanic stone nearly as hard as granite, quarried from a source over 90 kilometers distant, across some of the most difficult terrain on the continent. Andesite does not yield easily to hand tools. Cutting and shaping it with the copper and bronze implements available to Andean cultures of the period would have been, according to some engineering estimates, a process requiring not just skill, but timescales that strain credibility for the volume of finished stonework at the site. And the finishing is not rough. The famous H-blocks of Puma Punku, rectangular stones cut with interior notches, drilled holes, and perfectly flat interlocking faces, display right angles accurate to within a fraction of a degree. Some faces are so flat that modern engineers using laser measurement tools have found deviations of less than 2 millimeters across a meter-long surface. The drilled holes found throughout the site are uniform in diameter, with some showing evidence of a rotational cutting technique that leaves marks inconsistent with hand chiseling. How was this achieved? 3 theories dominate the discussion. The first proposes an underappreciated mastery of stone-on-stone abrasion, combined with sand as an intermediate cutting medium, a slow, labor-intensive process, but one that, given enough time and enough workers, could theoretically produce these results. Critics of this theory point to the sheer uniformity of the cuts as difficult to replicate by hand alone, particularly the interior right angles of the edge blocks. A second theory suggests that Tiwanaku culture may have possessed metalworking techniques more advanced than currently credited, potentially including tools we have no surviving physical evidence for, tools that did not survive, corroded away, or were repurposed by later cultures. A third and more speculative theory proposes that the blocks were cast rather than carved, poured using some form of stone composite technique, similar in principle to modern concrete, then finished by hand. Proponents point to microscopic bubble-like inclusions in some samples as possible evidence. Mainstream archaeologists remain highly skeptical, noting the technique has never been successfully replicated using only period-appropriate materials. What is not in dispute is the site's abrupt end. Around 1000 CE, Tiwanaku was abandoned, possibly due to a prolonged drought that crippled the region's agriculture. The people who built Puma Punku left before finishing it. Half-carved stones still sit in the surrounding fields, frozen mid-process, as though the workers simply walked away one afternoon and never returned. Whatever method they used, they took the knowledge of it with them. The stones remain. The instructions do not. Of every mystery humanity has inherited from the ancient world, none has been studied longer, debated more fiercely, or resisted final explanation more stubbornly than the Great Pyramid of Giza. Built during the reign of Pharaoh Khufu, around 2560 BCE, the pyramid originally rose to a height of 146.6 meters, making it the tallest human-made structure on Earth for nearly 3,800 years, a record unbroken until the completion of Lincoln Cathedral in the 14th century. The scale alone is staggering. An estimated 2.3 million limestone blocks, averaging 2.5 tons each, with some interior granite blocks weighing as much as 80 tons. Conservative estimates suggest the pyramid was completed in roughly 20 years, which, if accurate, would require setting a new block into place, on average, every 2 to 3 minutes, continuously for 2 decades. But raw scale is not what troubles engineers most. It is precision. The pyramid's base is level to within just 2.1 centimeters across its entire 230-meter span. Its four sides are aligned to true north with an average deviation of only 3 minutes and 6 seconds of arcade, an accuracy of better than 1/15 of 1 degree. Modern construction projects using satellite positioning technology do not always achieve alignment this precise. The ancient Egyptians achieved it using, as far as the archaeological record shows, sight lines, shadows, and the stars. How they moved the stones remains debated, though less mysterious than it once was. A 2018 study of Papyrus Jarf, a diary kept by an official named Mirror, along with the 1990s discovery of a purpose-built harbor near the pyramid, confirmed that massive limestone blocks were transported by boat along a now-vanished branch of the Nile, then hauled the final stretch using sledges over wetted sand, a technique physically demonstrated to reduce friction dramatically, confirmed by Egyptian tomb paintings depicting workers pouring water in front of a sledge. What remains genuinely unresolved is the internal construction method, specifically how blocks were raised to the pyramid's upper levels, and how the king's chamber's roof, built from 9 granite beams weighing up to 80 tons each, was installed with such precision at a height of over 43 meters. Ramp theories remain the leading explanation, though which type of ramp? A single straight ramp, a spiraling external ramp, or an internal spiral ramp threading through the pyramid's core, is still contested, with evidence for each found at various pyramid sites across Egypt, but no definitive proof matching Giza specifically. A 2017 muon scanning project, Scan Pyramids, detected a previously unknown void above the Grand Gallery, at least 30 meters long, with a cross-section similar to the gallery itself. Its purpose remains completely unknown. It has never been physically accessed. We do not know if it is a structural feature, a hidden chamber, or something else entirely. Nearly 4,600 years after its completion, the Great Pyramid still holds spaces we have detected but never entered, questions we have narrowed but never closed. Above the city of Cusco, on a hillside overlooking what was once the capital of the Inca Empire, stands a fortress wall unlike anything else on the American continent. Sacsayhuamán was constructed under the Inca Empire, likely beginning under the reign of Pachacuti in the mid-15th century and continuing under his successors, though some researchers argue portions of the site's foundation may predate the Inca entirely. Built by an earlier culture the Inca inherited and expanded upon. The site's defining feature is its zigzagging outer wall, built from megalithic limestone blocks, the largest estimated at over 125 tons, standing nearly 8.5 meters tall. What sets these stones apart is not simply their size, but their shape. Unlike the rectangular blocks of Egypt or Lebanon, the stones of Sacsayhuamán are irregular polygons, some with as many as 12 distinct faces, fitted together with such precision that, as at Baalbek, no mortar was used and no blade can slide between the joints. The Inca had no iron tools. Their primary cutting implements were stone hammers made of harder rock, hematite, and other dense minerals used to slowly pound softer limestone into shape through repeated percussion. Experimental archaeology has confirmed this method works, and Inca quarry sites show partially finished stones with visible pounding marks consistent with the technique. What remains far harder to explain is the fitting. Each irregular block was apparently shaped to match its specific neighbors, not cut to a standard template and forced together, but individually customized so that a 12-sided stone interlocks seamlessly with the 6 differently shaped stones surrounding it. This is not simple stacking. It requires either an extraordinary process of trial fitting, repeatedly test placing multi-ton stones, marking contact points, removing the stone, and refining the cut, or a method of measurement and planning far more sophisticated than the tools alone would suggest. Some engineers have proposed the Inca may have used a technique of grinding stones together directly, using one block as a template against which its neighbor was abraded to a matching profile, a process that would explain the seamless fit but would still require enormous time investment per block, especially at this scale. The irregular, interlocking design is not merely aesthetic. It has proven remarkably effective against seismic activity. The polygonal joints allow individual stones to shift slightly during an earthquake and resettle into place, a kind of ancient shock absorption that has helped the wall survive centuries of Andean seismic activity, essentially undamaged. While more rigid Spanish colonial structures built nearby with rectangular masonry have repeatedly collapsed and required rebuilding. Whether the Inca engineered this seismic resilience deliberately or arrived at it as a byproduct of their fitting method is itself unresolved. What is certain is that whoever solved the puzzle of Sacsayhuamán's wall solved it so well that the solution has outlasted almost everything built around it since. In 1901, sponge divers working off the coast of the Greek island Antikythera discovered a shipwreck dating to approximately 70 to 60 BC. Among the recovered artifacts, statues, coins, glassware, was a corroded, unremarkable lump of bronze that sat in a museum drawer for years before anyone recognized what it actually was. It would take decades and eventually high-resolution X-ray and CT imaging in the early 2000s to reveal the truth. The lump of bronze was not scrap. It was a machine, a geared mechanical device containing at least 30 interlocking bronze gears, the smallest with teeth just over a millimeter apart, housed originally in a wooden case roughly the size of a shoebox. Analysis of the gear ratios revealed the device's function: an astronomical calculator capable of predicting the positions of the sun and moon, forecasting lunar and solar eclipses years in advance, tracking the 4-year cycle of the ancient Olympic Games, and modeling the irregular motion of the moon using a clever gear-on-gear system that anticipated the moon's elliptical orbit. A level of astronomical sophistication historians did not believe existed for another 1,400 years. Nothing else like it exists in the archaeological record. Not a simpler prototype, not a cruder predecessor, not even a clear successor. The Antikythera Mechanism appears in the historical record fully formed, then vanishes just as completely. The next known device with comparable mechanical complexity is a European astronomical clock built in the 14th century, over a millennium later. This absence is, in its own way, the deepest part of the mystery. Complex mechanical technology does not typically appear without a lineage. Earlier, simpler devices refined over generations into a masterpiece. Either that lineage existed and every trace of it has been lost, or the Antikythera Mechanism represents an isolated technical achievement, developed by a single workshop or tradition that left no other surviving evidence of its methods. Ancient texts offer tantalizing hints. The Roman writer Cicero references a bronze device built by Archimedes capable of modeling the movements of the sun, moon, and planets, a description matching the Antikythera Mechanism's function closely enough that some researchers believe the mechanism may be connected to, or even a descendant of, Archimedes' own workshop tradition, based in Syracuse over a century before the ship sank. If that connection is real, it implies an entire tradition of Hellenistic precision engineering that has otherwise vanished almost without trace, swallowed by the same fires, wars, and centuries of neglect that destroyed the Library of Alexandria and so much else of the ancient world's written knowledge. We do not know who built it. We do not know how many were built. We do not know what was lost when whatever school of craftsmen who made it disappeared. We only know that somewhere in the 1st or 2nd century BCE, someone built a machine to model the heavens, and no one else, anywhere on Earth, would do so again for over 1,000 years. On Salisbury Plain in southern England stands the most recognizable prehistoric monument on Earth, and, despite more than a century of excavation, still one of the least understood. Construction at Stonehenge occurred in phases over an extraordinary span of time, beginning as early as 3000 BCE with a simple circular ditch and bank, and continuing through roughly 1500 BCE with the erection of the massive sarsen stones that define the monument's iconic silhouette today. That means the site was actively under construction, modification, and use for close to 1,500 years, longer than the gap separating us from the fall of the Western Roman Empire. The sarsen stones, the largest uprights, weigh up to 25 tons each and were sourced from quarries roughly 25 kilometers north, a transport achievement significant on its own, but not the site's deepest mystery. That distinction belongs to the smaller bluestones. Geological analysis has definitively traced the bluestones to a specific set of outcrops in the Preseli Hills of Wales, a distance of approximately 225 to 240 kilometers from Stonehenge, depending on the route taken. This is, by a wide margin, the longest confirmed transport distance for any megalithic stone in the prehistoric world. Two competing theories attempt to explain this distance. The human transport theory holds that Neolithic builders moved the 2 to 4 ton bluestones overland using sledges and log rollers, or via a combination of river and coastal rafts using rafts, an effort requiring sustained, organized labor across what would have been, at the time, several distinct tribal territories, implying a level of large-scale social cooperation not otherwise well documented in Britain at this period. The glacial transport theory proposes something stranger, that the bluestones were not moved by human hands over that entire distance at all, but were instead carried most of the way naturally by glacial ice sheets during the last ice age and deposited much closer to Salisbury Plain, meaning Neolithic builders may have only needed to move them the final few kilometers. The glacial theory would resolve the transport problem, but it raises a new one. No confirmed glacial deposits containing bluestone have ever been found anywhere near Salisbury Plain, despite extensive searching. Until such evidence surfaces, the theory remains unproven, and the human transport theory, however logistically staggering, remains the leading explanation by default. Then there is the deeper question neither theory resolves. Why go to such extraordinary lengths for these particular stones at all? Sarsen stone, suitable for monument building, was available far closer to Stonehenge. The bluestone's significance appears to have been tied to something beyond structural necessity, a belief that the stones themselves carried meaning, power, or memory from their place of origin. Recent excavations at the Preseli quarry sites have uncovered evidence of deliberate quarrying techniques dating to almost exactly the estimated construction period at Stonehenge, including stone and wood wedges still lodged in extraction points, as if the workers stepped away mid-task and never returned. Why these specific stones? Why this specific distance? Why a monument maintained and rebuilt across 15th centuries by generations who could never have met one another, working toward a purpose none of them left explained? Stonehenge does not answer these questions. It has never needed to. The stones have stood regardless for 5,000 years, waiting. 6 sites, 6 civilizations, separated by oceans, by centuries, by tools we can trace and tools we can only guess at. And yet the same question sits at the center of every one of them. How did they do this? And why does the answer keep slipping just out of reach? Baalbek's largest stone still lies unfinished in its quarry. Puma Punku's builders vanished before completing their work. Giza still holds a void we have found but never entered. Sacsayhuamán's walls still stand while newer structures around them have fallen. The Antikythera Mechanism appeared once, perfectly, and was never seen again. And in the hills of Wales, the wedges are still lodged in the stone, exactly where they were left. Every generation believes it has finally caught up to the ancient world, and every generation, standing in front of these stones, finds itself asking the same question the last one did. What did they know that we still don't?